In this video, I am going to show you how to solve higher order linear homogeneous differential equations. In order to solve equations like that, the first thing is to find the roots of the auxiliary polynomial. And once you find those roots, then we have these cases. Case 1, the roots are real distinct. By distinct, I mean the roots are not repeated roots. So let's say in case 1, let's assume that our polynomial for the differential equation is, after factoring out, we are going to have m minus a times m plus b times m plus c equal to 0. So in this case, our roots, let's assume, are real. M1 will be equal to a, M2 will be equal to minus b, and M3 will be minus c. So the general solution for this case, when the roots are real and distinct, is y equal to c1 e to power ax plus c2 e to power bx plus c3 e to power minus cx. This is minus bx. So this will be the solution for this case, when the roots are real and distinct. Now, when the roots are repeated, let's say for example, after factoring, we are going to have m plus a to power 3 equal to 0. So here our m will be equal to minus a 3 times. So the general solution for the case like this will be E is equal to C1 e to power minus ax plus C2 x e to power minus ax plus C3 x squared e to power minus ax. So this will be the general solution for the repeated roots. And the last case, case 3, let's say the roots are imaginary. Let's say the root will be, let's say the root will be m equal to a plus or minus bi. So in case like this, the general solution will be equal to e to power ax multiplied by c1 cosine of bx plus c2 sine of bx. So this will be our general solution for the case that our root is imaginary. Now, in a differential equation, we might have case 1, 2, 3, or a combination of all of them. So let's solve some examples. Let's start with a basic example. I've written some problems here. Let's see. Let's say we have a differential equation d2y over dx2 minus 5 dy over dx equal to 0. So the first step is find the roots of auxiliary polynomials. So we can write this as m squared minus 5m equal to 0. So if we factor this out, factor m, we are going to have m times m minus 5 equal to 0. So our solution m1 will be equal to 0 and m2 will be equal to 5. So the general solution for this differential equation will be equal to c1 e to power m1x, which is 0x, plus c to power plus c2 e to power 5x, which e to power 0 is 1. So the solution, the general solution for that differential equation will be y equal to c1 plus c2 e to power 5x. Now let's look at another problem. Let's say we have a problem d2y dx2 minus 25 is equal to 0. So the auxiliary polynomial for this differential equation will be m squared minus 25 is equal to 0. So if we factor this out, we can write this as m minus 5 times m plus 5 is equal to 0. So our roots will be m equal to 5 and m equal to minus 5. So our general solution for this differential equation will be equal to c1 e to power 5x plus c2 e to power minus 5x. So this will be the general solution for this differential equation. Now, let's look at another problem. Let's look at this problem. d3y over dx3 plus 4 d2y over dx2 plus dy over dx minus 6 equal to 0. So the auxiliary polynomial for this differential equation will be m3 plus 4m squared plus 1 minus 6 is plus 1m minus 6 equal to 0. So once we factor this out, we are going to have m minus 1 times m plus 2 times m plus 3. In solving the high order differential equation like this, the most challenging part is the factoring. And in this video, I am just showing you how to solve the differential equation. Knowing your factory is your math basics, and you got to know how to do the factory. And I am sure there are a lot of videos on YouTube that you can follow and learn how to do that. So you have to practice your factoring very good. So once we factor this polynomial, this is what we get. So our roots will be m equal to 1, m equal to minus 2, and m equal to minus 3. So the general solution for this differential equation will be equal to y equal to c1 e to power x plus c2 e to power minus 2x plus c3 e to power minus 3x. So this is the general solution for this differential equation. Let's look at another problem. Let's look at this problem. d3y over dx3 plus 3 d2y over dx2 plus 3 dy over dx plus y equal to 0. So we can write the auxiliary polynomial for this differential equation is mq plus 3m squared plus 3m plus 1 equal to 0. So once we factor this out, you are going to have m plus, this is m plus 1 cubed. So our root m is equal to minus 1 3 times. So the general solution for this differential equation will be equal to y equal to c1 e to power minus x plus c2x e to power minus x plus c3 x squared e to power minus x. So this is the general solution for this differential equation. So let's look at another equation. Let's look at this equation. d2y over dx squared plus 4 dy over dx plus 25y equal to 0. So to solve this, the auxiliary polynomial for this differential equation will be m squared plus 4m plus 25 is equal to 0. So this is one of those problems that we cannot factor this out. So in order for us to solve for m1 and m2 will be equal to minus b, which is minus 4, plus or minus the square root of b squared, which is 16, minus 4ac, a is 1, c is 21, 4ac is 100, divided by 2a. a is 1 divided by 2. So this will be equal to minus 4 plus or minus a square root of 84 divided by 2. So this will be so this will be equal to, this is minus the square root of minus 84. So this will be equal to minus 2 plus or minus a square root of 21. I. The square root of a negative 84. So this has been, I wrote 84 as 2 times 21, 2 comes out, and divide by that 2, so that would be the answer. So the general solution for this differential equation is e to power minus 2x multiplied by c1 cosine of a square root of 21x plus c2 sine of a square root of 21x. So this is the general solution for this differential equation. Now, let's do one more problem. Let's assume that we have a differential equation that the auxiliary polynomial, after we factor, we come up with this. We come up with m minus 2 multiplied by m plus 3 multiplied by same problem that we had, multiplied by m squared plus 4m plus 25 equal to 0. Let's assume we have a differential equation that are auxiliary polynomial. After we factor out, we get this. We already know the solution for this part, which is this part. This is the solution to that part. And let's also say that we have a square here. So our general solution will be equal to c1 e to power 2x. Now we have m equal to minus 3 a couple times. So plus c2 e to power minus 3x plus c2 x e to power minus 3x plus the solution for that plus e to power minus 2x times, sorry, this was c3 times c4 cosine of a square root of 21x plus c5 sine of a square root of 21x. See, we have 5 constants because our order is 5. We have 2 and 2, 4 and 5. So our order is 5th order, so we are going to have 5 constants. So this will be the general solution for the differential equation with this auxiliary polynomial. This higher order differential equation, as I mentioned before, the challenging part is to do the factoring. And so work on your factoring. If you are not that good at it, watch videos, and if you want me to post a video regarding how to factor the polynomials, let me know, and I will do a video just for that. I hope you liked it. Thanks.